Hello, everyone, and welcome to this SAS Explorer presentation, Travel Greener and Better. I am Stefanus Wiguna, and today I'm going to share with you about a project we did earlier this year in support of SAS Sustainability Initiative. So let's get started. SAS is proud to be part of the Data for Good movement, which encourages using data in meaningful ways to solve humanitarian issues around poverty, health, human rights, education, and the environment. So let's talk about SAS net zero emissions. So SAS has a 2050 net zero carbon emissions goal and targets to reduce absolute emissions 25% by 2025 and 50% by 2030. SAS is taking a multi-pronged approach to accomplish this, from green building on our smart campus to employee commute and business travel. So business travel accounts for more than a quarter of SAS total pre-pandemic direct and indirect emissions, making it a natural focus for helping us to get to net zero. And that's why earlier this year, as part of SAS Hackathon, we worked on the project to help resolve real business travel challenges. So here's an overview of what we worked on and what I will go over in this presentation. I will go over the data exploration and visualization phase, where we started to get a better understanding of the data, which is SAS travel data since 2017. How we then built predictive models to determine if a hotel was preferred or not, and how we then tune these models and compared for result and performance. I will also go over how we analyze whether a hotel rate code is good and the rate's volatility. And building on top of this rates analysis, I will go over how we try to determine which hotels should be preferred. So I use the term preferred hotels quite a few times already. And just to quickly explain what it is, based on certain criteria in each metro region, SAS Travel designates certain hotels as preferred and negotiates lower rates for these hotels. And going back to the list, last but not least, I will go over our carbon footprint analysis of these SAS trips. A lot to cover, so let's jump right into data exploration and visualization. So we started with data exploration and visualization, where we tried to better understand the data and also to get some preliminary insights. And you'll see in the following slides several examples of what we were able to do for this exercise using SAS Visual Machine Learning and SAS Visual Analytics. We use SAS VML to get a better understanding of the data and the metadata. For example, what kind of actual data is available and what the data types are. In this example, the column was preferred at booking towards the lower left and highlighted in blue indicates whether the hotel is a SAS designated preferred hotel. We also get to sample the actual data to get a glimpse of the overall data quality and to identify outliers. For example, missing or extreme values such as the one highlighted in yellow towards the middle right, which could be valid depending on the negotiated contract, but could also point to potential data entry error. We also use VA to experiment with reports and to visualize the data. In this example report, we show a view of nearby hotels in the Cary metro region. You can also view additional information such as the room counts by hovering over the region. In this other report, we started to get insights on how often rate is over the limit and in what regions. In this example, where we've anonymized the region names for privacy, as you can see towards the bottom and highlighted in red, it looks like a lot of the bookings for region 16 were over the limit. So something to look into. And here is an example report on carbon footprint. In this case, showing the amount of tree seedlings needed to offset total emissions produced by SAS trips. Obviously, the numbers for the last 2 years dropped due to the pandemic. So these are just a few sample reports we created as we explore and evaluate the data. So now that we had some ideas on what kind of information we had to work with, we started building predictive models using VA and VML. And we built the predictive models in different ways. In VA, as you can see on the top left, we built a first model to predict hotel rates limit and use the derived predicted values as predictors to then build a second model to predict if a hotel was preferred or not. In VML, as you can see on the lower left, we used MLPA, which stands for Machine Learning Pipeline Automation. So MLPA is simply a one-click pipeline exploration, and it's a feature of SAS VML. It automates the tasks required for building machine learning models. And these tasks can include data preparation, feature engineering, model selection, and hyperparameter tuning. Now, since there are so many combinations of features, models, and hyperparameters to try, it can be very time consuming to perform these tests manually by trial and error. So the automation of this task and pipeline with MLPA gives you a good start at a machine learning workflow. And finally, as you can see on the right-hand side, we also built 3 gradient boosting models manually in VML, where the first model did not use auto-tuning, a second model that used auto-tuning with default settings, and a third model that also used auto-tuning but with optimized settings. And comparing these models, we found that using auto-tuning with optimized settings gave us the best result. So speaking of tunings, many automatic pipelines in VML will already incorporate auto-tuning, but we realized that we can adjust this default auto-tuning settings further and see what the impact is. So for tuning, we are shooting to maximize the KS value, which is the measurement of the performance of the model. And for our updated settings, we increased the number of iterations and the limit of total models. Highlighted in the table in blue, we see that training with no tuning led to a KS value of roughly 0.67. Using the default tuning led to a fairly big jump in KS to 0.88. And increasing the allowed evaluations and iteration increased KS even further. The ROC plot also very clearly showed the improvement and showed that train, validate, and test are similar for each scenario. So moving on to hotel rates analysis. In this task, we're trying to help SAS Travel to evaluate whether a rate quote received from a hotel is good. We wanted to evaluate a hotel's price quote based on some criteria and also comparing that with nearby hotels. And for this task, we use SAS Studio and CAS to write the analytics procedure and to analyze and manage the data. And we use VA to visualize the results. So we developed the analytics code in SAS Studio. And when evaluating a rate, you can call this interface with the hotel ID and quoted rate. You can also provide optional parameters to filter competitors and outliers. The results are then uploaded to CAS to drive the VA report. So one important metric SAS Travel has considered is the hotel rates volatility. In this example VA report from our analytics procedure, we are showing the volatility in Cary Metro region. So to measure volatility, you can use variables such as standard deviation. But more importantly, we want to measure volatility against other hotels in the market. So we borrow this idea of beta value, which how Wall Street evaluates stocks volatility. And we compared the beta value of each hotel, where the smaller beta value indicates less volatility. And as you can see in this report, where we've anonymized the hotel names for privacy, Hotel 7 has the highest rates volatility in the region. In this other example report, we are taking a closer look at one of the hotels in Cary Metro region, where the quoted rate is compared to historical and market rates, as well as future forecasted rate. And as you can see in this example, the historical rate is fairly consistent with the quoted and market rates. And we hope this insight can help to evaluate how the quoted rate can be expected to perform in the future. I wanted to note that the same analytics procedure can be used to report on any hotel just by changing the input data. Now, building on top of our hotel rates analysis, we tried to solve the preferred hotel optimization problem. So the business problem here is to determine which hotels should be preferred. And a secondary decision is whether a booking request for a non-preferred hotel should trigger a recommendation to a nearby preferred hotel. And the preferred hotel optimization problem is to find values for the corresponding decision variables to minimize the total moving cost to preferred hotels, subject to certain constraints, such as the ones listed here. And for this exercise, we use the opt model procedure in SAS optimization to formulate and solve this problem. Here is a portion of the proc opt model code. We wanted to use the powerful mixed integer linear programming solver, but one of the constraints is nonlinear because it includes the product of the continuous x variable with the binary y variable. Now, you could manually linearize this constraint by introducing a new decision variable together with the linear constraints, as shown here commented out. But a recently added feature automatically performs this linearization on your behalf if you specify the linearize keyword in the solve statement as seen towards the bottom. In this example report from our optimization procedure, if you limit the number of preferred hotels to 2 in the carry region, the resulting optimal solution recommends preferring the Embassy Suites across from SAS and the Hampton Suites just south of campus, both indicated by the purple circles. You can also see that some non-preferred hotels are recommended to have their bookings redirected to these 2 preferred hotels, as indicated by the gray arrows. I also wanted to note that the same optimization code can be used to solve the problem for any region just by changing the input data. Carbon footprint. So we have been and are very excited to contribute to sustainability awareness and initiatives. And for our carbon footprint analysis, we use SAS Studio and VA to explore the data, post-process them to get insights, and build a data quality dashboard tool that we hope will help in future analysis and decision making. So first, let's start with an overview of SAS trips impact. So since 2017, SAS travelers spent just over 50 million minutes on airplanes alone. And that's almost 37,000 full days. And to offset all these flights, we would need to plant over 1 million tree seedlings. And that's more than the sequestration of all the trees on our SAS Carryman campus. So looking at the numbers this way also allows us to start considering the carbon impact along with dollar cost and time. Now, a reduction in carbon impact does not necessarily need the exact same percentage reduction in travel if we can identify high-emitting trips. And we found out that a good number of trips have the purpose recorded in the data. And these tend to be higher carbon impact trips. So based on this observation, we built a dashboard tool to find potential data quality issues in hopes of improving the data and the decisions. A few example criteria we use to screen the data are missing trip purposes, missing or unknown customer names, and missing rates for non-preferred hotels. And this tool can also be forward-looking by reporting only data quality issues for future trips that have not yet occurred, which allows for follow-up. So as the world is going through the pandemic, we do have an opportunity as we define the future of work to modify how we travel in small incremental ways. And I hope that our project can help raise awareness and provide useful insights on the environmental impact of business travel, including our own. I'd like to reiterate SAS commitment to sustainability and fighting climate change. And then we are proud to be part of the Data for Good movement. I would like to end with another quote from Dr. Goodnight that at SAS, sustainability is a commitment to make a positive impact in everything we do. Please visit SAS Data for Good and Net Zero Emissions to learn more about SAS initiative on sustainability, and also the Model Studio breakout session to learn more about SAS Visual Machine Learning. That concludes my presentation for today. Thank you for watching, and I hope that you find it informative.